Hi, I'm Kian, and in this video I'm going to show you how to solve a real application of partial differential equation using separation of variables. So you have this equation, the first partial derivative of x, function of two variables x and t with respect to t is equal to the partial derivative of the function with respect to x minus b, which is a constant, times the function. So what I'm going to do first, which is basically what we do for partial differential equation using separation of variables, is basically to let the solution f of x and t, or in this case I said it's u, to be a product of two functions with two different variables. So in this case, the function would be the final answer, or the final solution would be a product of a function of f of x times a function of g of t, which all together would bring to a unique solution, or a general solution more, of this partial differential equation. So let's get started. So if we use this hypothetical solution of f of x times g of t, if we actually find each component of the equation, we can solve it. For example, for the left-hand side, if you find the partial derivative with respect to t, we can basically take the derivative of g of t, becomes g prime of t times f of x. And f of x is a constant when taking partial derivative with respect to other variables, so it remains the same. For the next term, the right-hand side, the partial derivative with respect to x is basically the same as the previous one, but it's opposite. So basically we take the partial derivative of f of x, which becomes f prime of x times the g of t, which acts as a constant and doesn't change, and then we get minus b times the function f of x times g of t. Now, to neat things up, I'm going to bring the b f of x g of t to the right-hand side by adding, and I'm going to factor out an f of x. If I do, we get f of x times g prime of t from here, plus b times g of t from the right-hand side that I added. And this is equal to simply the right-hand side, f prime of x times g of t. Now, a key part of partial differential equation and separable separation of variables is to have all the variables in one side and the other variables on the other side. So what I'm going to do is to divide both sides by f of x and to divide both sides also by g of t. In this way, I can get rid of the f of x on the left-hand side, and I can get rid of the g of t on the right-hand side. And if I do, the left-hand side will be all in terms of t, and the right-hand side would be all in terms of x. And I would get g prime of t over g of t, plus, and then b times g of t over g of t. The g of t is cancelled, so I just left off with b, which is a constant. And this is equal to f prime of x over f of x. Now, this condition where g prime of t over g of t plus b is equal to f prime of x over f of x only occurs when both of them are equal to the same constant, because they can't equal to a variable in terms or expression in terms of x or t. That wouldn't make sense. The only way that they can be equal is, for example, both of them be equal to 1 or 2 or 0. So I'm going to let that constant to be k. And now I can form two ordinary differential equations to solve for the functions g of t and f of x. And that's what I want, because we don't want to tackle with partial differential equations. We want to tackle with ordinary differential equation that we know and have practiced before. So I've turned a partial differential equation to an ordinary differential equation. And if we do that for the first one, I basically wrote g prime of t as dy over dt, the same thing, is equal to, and then I subtracted b from both sides, so I get parentheses k minus b, and then multiply g of t, which I wrote as y, because that's the function. Now I can basically do what we do for separable differential equation, ordinary separable differential equation. Then I can divide by y, multiply by dt, take the integral, and solve, and I get the final solution for this function y of 1 to be c times e to the power of parentheses k minus b times t. Now, this is the first part of my final solution to the partial differential equation. Now we need to find a function in terms of x. That's why we have the second part. F prime of x over f of x equals k. Now I wrote f prime of x as dy over dx, similar to how I did last one. And I just multiplied both sides by f of x or y, So I get dy over dx is equal to ky. And if I solve it using the similar methods of separable differential equations, divide by y, multiply by dx, take the integral and simplify, I get y to be some constant b times e to the kx. Now, I know that I have both part of my solution, so I have to simply multiply them. So our final answer, u, or f of x and t, is equal to b e to the kx times c e to the k minus b times t. Now, I want to combine my solution so it's more simpler, and I do that by saying that b times c is another constant. I can just call it a. And then I can basically combine the powers to get e to the power of kx plus kt minus bt. I just distributed the k minus b times t. And that is my final solution. And you can, in fact, check the solution. This is the